Hello and welcome. We're so glad that you've joined us today for our webinar, The Gut Microbiome 101. My name is Christy Lansdowne, and I serve as ACT's Executive Director. Achieving Cures Together is a nonprofit that was founded 11 years ago to advance microbiome research, restore health, and transform lives. We are proud to partner and support researchers around the country who are investigating the links between our health and our gut microbe communities, including the University of Minnesota Microbiota Therapeutics program and Dr. Alexander Khoruts, who will be sharing his expertise with us tonight. Before we begin, I do want to highlight a couple items. We recently launched a new website with enhanced features, including an interactive map featuring clinical trials, research partner highlights, upcoming events, patient experiences, and more, and we hope it can be a useful tool for you. We also have an upcoming in-person event in Minnesota, Growing Hope, on September 11th at the winery at Sovereign Estates. We're thrilled to have Dr. Khoruts join us again as a guest speaker at the event. In addition, we will also be joined by Dr. Richard Bedlack from Duke University. Dr. Bedlack is leading groundbreaking research with microbiota transplant therapy and amyotrophic lateral sclerosis, also known as ALS or Lou Gehrig's disease, which is a progressive neurological disease. If you're interested, you can find out more details on our website and also register, which is achievingcures.com. We'll also list that in the chat momentarily here. Also, this webinar is being recorded and will be shared with registered attendees in the coming days. You're more than welcome to share with any other interested family members or friends. And we also want to encourage you to submit any questions throughout the webinar using the Q&A or the chat features. We'll plan to reserve time at the end of the presentation for Dr. Khoruts to answer as many questions as possible. It's now my pleasure to introduce our keynote speaker, Dr. Alexander Khoruts. Dr. Khoruts is a leading scientist and gastroenterologist at the University of Minnesota, and he's internationally recognized for his pioneering work in microbiota transplant therapy. We're honored to have Dr. Khoruts as a partner and with us today to share his expertise and his insights, and want to thank you for being with us this evening.
Thank you so much, Christy. Let me get my talk up. All right, oops, that's not it. So thank you for this opportunity to talk about this this topic. And I'm excited to talk about it because I entered this field about 20 years ago. It was an incredible moment because I realized an entire organ was being discovered in the human body, and it was happening in my early midlife career. And what else could I do but redirect my efforts at the university and just focus on that? Scientifically, it is paradigm changing. It is has implications for all aspects of human health and disease. But at the same time, I realize that the public is inundated with all kinds of hype. Some of it justified, most of it not. And it's critical that people are able to cut through the noise and understand what is real, what is not, what is useful, what is important for them. And these are the kinds of messages that people are getting whenever they visit a store, whenever they open internet, if they happen to type in microbiome questions a couple times in their Google box, they'll get inundated with influencers and commercials and all kinds of advertisement. Um, Again, some of it has some shades of truth and where science may be heading. Most of it is not really. So I'll start with a very fundamental question. It is so fundamental that nobody really knows the answer. What is a healthy gut? So there's no agreement among researchers or physicians what that is. Now, we can measure your heart, your lung, your kidney function, but can we really measure gut health? So for the heart, we have a stress test. For lungs, you can breathe in a tube and it'll measure how much you can blow and what's the lung capacity and how fast it blows. For kidneys, it's even easier. You just do a blood test and it'll measure what's called glomerular filtration rate or estimate from serum creatinine, and you get an idea of the kidney function. There is no such test for the gut. Now, we can recognize what's an unhealthy gut. And so here's some common diseases that clearly are related to gut problems. The most common by far is so-called irritable bowel syndrome, or it's one of the members, one major member in a family of disorders, what are called the disorders of gut-brain interaction. Uh, these tend to be quite symptomatic. The typical symptoms involve abdominal pain or cramps. That's a cardinal symptom. Irregular bowel movements. Sometimes they're diarrhea, sometimes they're constipation. There's different versions of this. Bloating, gas, nausea. They tend to, in many patients, be exacerbated by stress, anxiety, but it is a syndrome that's probably more than one. Multiple different factors and elements can drive similar symptoms. Sometimes we can tease it apart and understand it. Sometimes we really can't. And I am sure there's a lot we don't understand. But in a typical gastroenterology office, this is one of the more common problems that we're seeing. There's also inflammatory bowel diseases, Crohn's disease, and ulcerative colitis. These are clearly inflammatory conditions. There's inflammation in ulcerative colitis. It's all throughout the colon or part of the colon, but it's very characteristic geography of the colon with rectum, the last very part always involved. Crohn's disease involves the entire GI tract, but it's skipping. There are parts that are normal, parts that are quite involved, and the severity is highly variable. There's colon cancer. Now, colon cancer is among cancers only number two, a killer among all cancers. Number one is still led by lung cancer. It happens to be number three in men and number three in women. And you wonder, how is this number two overall? And that's because women get breast cancer and men get prostate cancer. There's also a common condition, diverticulitis, which affects a small fraction of people who have what's called diverticulosis. These are little pockets that form in the colon, primarily as people age, and they can get inflamed. These are some of the common things. So when we see something like that, well, we can all agree that is unhealthy. But how do we know what is healthy? Considering that, as we'll see shortly, the gut is more than just concerned with just gut alone. It has implications for the entire body. It interacts with the immune system, with the nervous system, with our energy, metabolism, and there may not be any obvious problem in the gut, but there's problem elsewhere. So that's where the question comes in. So before we get to that, um, let's just review basic physiology. So the human digestive system, it's a big system. You have obviously the structural elements. The food goes in your mouth, then the esophagus, then enters your stomach, which is a temporary pouch that does some grinding and digestion. And then it is passed into the small intestine, where most of the nutrients are absorbed after further digestion. And then at the very end, it enters the colon where the digestive process is finished by microbes. About 5 to 10% of energy that we get from food is generated in the colon from microbial fermentation. Liver and pancreas are also part of the digestive system. They secrete bile and various digestive enzymes to help with the process. Now, what about this microbiome that's part of the digestive system? Well, if we kind of look mainly in the colon, that's where most microbes are, although they are present in the small intestine as well. And mainly in the colon, if you really zoom in at the microscope, you will see they're not just passively sitting there. Of course, they're there for their own purpose. It's a great place to be if you're a microbe because there's nutrient flow. And they finish the digestive process, as you can see. And as part of that fermentation that happens in our colon, we get some byproducts that are useful for the colon health itself. Um, and it's a mutualist relationship between our gut microbes and the human body. Mutualist means that both parties benefit from each other. There can be other relationships. All relationships are complicated. Uh, as you know, there could be parasitic relationship where one party is taking advantage of the other, or there could be kind of commensal, they're ignoring each other. But overall, really, the biology has driven the two parties to be mutualist in a healthy state. If we really look under the microscope, this is a picture of a mouse colon. On the right lower part of this figure, you see the host cells. They're blue. Then there is this green line, and that's a mucus layer that is part of the gut barrier. And then there's this colorful stuff on the upper left, and that's all microbes. It's a highly dense, organized microbial community. Some of these microbes are actually grazing on the mucus. Some of them are in the lumen, kind of in the middle, and they are eating whatever's coming through. Uh, in general, in humans, that tends to be plant-based fibers because those are not very well digested in the small intestine. They become food for microbes. And in fact, this is why the doctors always tell patients you should eat more fiber. And that's whether they realize it or not. The reason for that is because that's what keeps that microbial community happy. A couple terms as I go through that, I will do a little bit of vocabulary so everybody is on the same page in case we do microbiome 102. So microbiota is a term. It is a community of living microbes that are present in a specific environment. And then you hear the term microbiome. They're very related. But basically, it encompasses all of the microbiota, that is the living microbes, but also their genetic material and the environment itself. And what is this? What are the components of these what are the different microbes? Well, there's bacteria. That's the major one. But in fact, the gut microbiomes contain all domains of life. So we have bacteria, we have fungi, we have eukarya. Those are the main domains of life. So there's maybe about 500 different species or so of bacteria in this complex microbial community. There's also fungi like Candida. Um, there are eukaryotes like protists. Um, and there's a lot of viruses. For every bacterial cell, there are about 10 bacteriophage, that is, viruses that attack bacteria. They're not pathogens to humans, they are pathogens to bacteria. And this is really important in microbial ecology because there's all kinds of interspecies relationships, including prey and predator. So in this case, the bacteriophage is a predator, and bacteria are the prey. And of course, they have their own dynamics. But all of this complexity is actually important to keep this microbial community resilient and stable to various insults that can come across, which they do periodically. Um, and as I mentioned, this gut microbiome is integral to human physiology. So if you think about it on a daily basis, where does your immune system see the microbial world? Most of it is happening in the gut because that's where most microbes are. So this uh, means that the gut microbiome calibrates the immune system responses. Thus, the importance in connection to allergies and to autoimmunity and to cancer. Um, it is also important in communicating with the host about energy balance. What does that mean? That means your appetite. That means how the energy is harvested, digestion itself, and how is it spent. Um, Everybody knows these days about GLP-1 drugs. Well, the microbes, GLP-1 is based drugs are based on GLP-1 hormones that are naturally made in the gut, and they're made in part in response to microbial stimulation. Importantly, the gut microbiome also interacts with the nervous system. It happens to be only second to liver in terms of just the sheer size as a metabolic organ, that is, various chemical transformations that are made in the body. And so a lot of those chemical transformations produce substances that can talk to the nervous system. Um, it is not an accident that when people feel anxious, uh, they may feel some gut symptoms. And some of that gut stimulation is actually made by the gut microbes. It's also an open system. Unlike your heart, which is contained inside the body, or your lungs, or maybe lungs is not the best example, kidneys. Um, the gut is open. Stuff comes in, stuff comes out. And so it's very dynamic and it changes over time. There are important inputs that really determine its composition and function. That includes diet. It's kind of obvious because certain nutrients will feed the microbiome, and microbiome can also be starved if you're just eating ultra-processed foods. Social interactions happen to be important because we're not in germ-free environment. So how you grow up, with whom you interact, this is how you collect the microbes. And we'll mention maybe a little bit about that as we go. So another word, dysbiosis. What does that mean? It's thrown around a lot. I define it as altered composition and function of the microbiome that is detrimental to health. So there's a lot of variability in individual microbiomes, and they may be all versions of healthy. But if it is detrimental to health, that's what dysbiosis is. And so, what can be done to target the microbiome to make it healthier? Well, what about probiotics? This question always comes up, so I thought I would just handle it straight on. So, by definition, these are live microorganisms. They can be bacteria or yeast that, when given in enough amounts, provide a health benefit. Now, you already said, like, well, you don't know what a healthy gut is, so how can you provide a health benefit? And that is actually the core issue here. Um, but let's just go through the history of probiotics. I thought that's an interesting review. So, how do they originate? Where do they come from? Well, consider they emerged at the turn of the century of going 19th to 20th. And what was the context of that time? The context was that all the preceding the recent preceding recorded history was dominated by infectious disease. That was the main cause of death, ranging from Black Plague to smallpox to others. And for centuries, there are all kinds of theories that people had of what is the cause of all these maladies. Some of it was divine punishment. Ancient Greeks thought it was imbalance of humors, and this is where people came up with bleeding and leeches and such. And there was a common miasma theory, which is actually pretty close, that diseases originate from rotten food and foul smells. And then science happened. Louis Pasteur, probably the main figure here, uh, but also Robert Koch and Joseph Lister. These are really the founders of arguably the most basic theory in medicine, which is the germ theory of disease, which says germs cause disease, not divine punishment, not some humors, not the humor imbalance. They're microbes. They cause disease. Moreover, specific germs cause specific diseases. And there was a flurry of activity back then where one disease after another, cholera, tuberculosis, dysentery, they were able to find specific cause for every one of those diseases using very rigorous criteria, how to link one microbe to a specific disease. That really is still the dominant theory. That is the theory of how a lot of people think. And people thought, well, if there are bad microbes, maybe there are good microbes. Okay, so then after Louis Pasteur, the head of the Pasteur Institute in Paris was Ilya Mechnikov. He was a 1905 Nobel Prize winner for immunology. He discovered phagocytosis, that is, immune cells that engulf things like bacteria or debris, uh, very critical processes in the immune system in the body. He later in life also became a founder of the scientific study of aging, and in fact coined the term gerontology as the scientific study of aging. He was the first one to recognize that aging is actually a biological process worthy of study. But at that time, the leading theory of what of how aging happens was autointoxication. That is, toxins made by gut microbes drive aging and disease. And you could kind of understand it. Germs really got a bad reputation. They were cause of all kinds of diseases, so why not this? Um, Now there were others. Now, Mechnikov had his research going on in Paris. Um, in England, there was this famous surgeon, the surgeon for the royal family, Sir Arthur Lane, who figured that the common problems of bloating and constipation, mainly in young women, were caused by these germs, and the germs are in the colon. So he figured the colon needs to be removed. Um, that actually didn't work very well. In all likelihood, these patients suffered with irritable bowel syndrome, and removing their colon was a rather draconian surgery that left them with symptoms but without the colon. Nevertheless, actually, the surgical technique for how to remove the colon was developed by the surgeon for this indication, not for colon cancer. There was also Dr. Harvey Kellogg, you might recognize from some serials. His ideas are still pretty reasonable. Uneliminated waste in the colon putrefies and causes diseases, but his idea was let's give more fiber, and that will improve colonic transit, and that's what is going to be healthy. Oops, for some reason. It's okay. So a little bit more in the mix. So at the time, now we're still in the turn of the previous century, there were sensational and unsubstantiated reports of extreme longevity in Southern Europe and the Caucasus. And it's most certain that Ilya Mechnikov was well attuned to these stories and probably believed them. And at the time, in these cultures, there are two factors. One is fermentation is a traditional method of preserving the nutritional value of food. So they had a lot of kefirs and yogurts. The second was a cultural element. The oldest individuals in these cultures garnered the greatest respect. And they didn't really have any birth records. So when you're the oldest person in the village, um, and you want the most respect, you could inflate your age. So it was not uncommon for people to become 200 plus years old. Um, to connect the dots, there was a Dr. Grigorov, who was a Bulgarian scientist, isolated a microbe, Lactobacillus bulgaricus, it was called, from yogurt and sent it to Ilya Mechnikov. And what Mechnikov did was he cultured on a petri dish gut bacteria with this lactobacillus and noticed that in the presence of lactobacillus, the gut bacteria didn't grow very well. So there, that completes the entire proof because gut bacteria are kind of disgusting and yogurt is pleasant. And gut bacteria cause disease by autointoxication. Lactobacillus kills them. That's the fountain of youth. And so Mechnikov himself was consuming liters of kefir every day in trying to prolong his own life. Unfortunately, he died at age 70 of a cardiac disease. But there was the Mechnikov probiotic. You can see it already on the market back at the turn of the century. And in fact, even into the 1970s, this was how probiotics were advertised. So there's a woman from Soviet Georgia claiming to be 137 years old, and she's eating Danone yogurt. The global sales of probiotics generates about 80 to 130 billion dollars per year. Actually, the Asia Pacific is the dominant place, but the US domestic market is about 7 to 16 billion a year. Um, More than half the sales are from probiotic infused foods and drinks. So there's a little difference between probiotic infused foods and fermented foods. Fermented foods are ferment on their own. Probiotic is something that's maybe pasteurized and sterile, and then you add probiotic strains to that. Most common ones are lactobacillus, just like the Mechnikov strain, bifidobacteria, Saccharomyces yeast. What's the scientific evidence for these products being beneficial? It's minimal and highly biased by industry funding. So let's go through some myths. Number one, probiotics are proven to be beneficial in treatment of specific GI diseases. Facts. None of the existing probiotic products are actually regulated as drugs. That is, they didn't have to prove ever that they have efficacy for any medical diagnosis. They're all part of wellness industry. Having said that, there's good evidence that probiotics are helpful in prevention of necrotizing enterocolitis in preterm infants. That is about the only condition where we have solid evidence of that. Very limited and probably has nothing to do with the way people think probiotics even work. There's some evidence that they may be helpful in management of pouchitis, which is a very boutique kind of disease for people who lost their colon. Maybe antibiotic-induced diarrhea, that's controversial. Myth number two, probiotics restore and repopulate the gut microbiome with good bacteria. The first problem with that is you can't really classify bacteria into good or bad. From their standpoint, they're all good. From our standpoint, some of them are good, some of them are bad. Most of them have no moral value whatsoever. But The reality is, most of these microbes simply are transient passengers traveling through the gut. They're not going to stay there. They're not going to repopulate anything. They're not restoring anything. The colonization is minimal and highly variable. Um, they've even been shown to delay and impair normalization of gut microbiome after antibiotic exposure. That was a study that was probably the best study ever done so far, where normal volunteers took antibiotics and then they were given either probiotics, validated the strains that were on the label, uh, or just let recover on their own. And those that took probiotics actually recovered slower. Some of the potential benefits, if there are any, uh, maybe have nothing to do with microbiome ecosystem, but just passing microbes through the small intestine, which is an area that's not rich in microbes, could stimulate the immune system. And so there may be something there, but not by the way most people think about them. Um, More is better is another myth. So you may see a few colony forming units on the label. And you think if there's many more, that's better. Well, the reality is the potential effects, if there are any, are highly strain dependent. That is not even species, but a strain. So you can have hundreds of different lactobacillus species. Lactobacillus is a genus, but let's say it's further, Lactobacillus rhamnosus. There may be hundreds of strains and they have unique properties. A generic grouping of all products as probiotics equally good makes no sense whatsoever. And CFU really is a clinical manufacturing endpoint, has nothing to do with clinical endpoints. And concerningly, if you actually take a probiotic product off the shelf, take it to the lab and check, does it match the label? 90% of the time, it does not. Some other terms, prebiotics. That's food for the microbes. It's food ingredients digestible exclusively by gut microbes. These are mostly plant-based fibers. Then there's postbiotics. These are products of bacterial fermentation or even dead microbes or pieces of dead microbes. And then there's synbiotics, which is a mixture of probiotics and prebiotics, and there are some companies that will say they're going to analyze your stool and determine what probiotics you need, and in addition to that, maybe even a prebiotic cocktail. Uh, all hype. So, what do I tell my patients? Well, personally, I do not endorse use of any probiotic products formulated in capsules. They're probably harmless, but largely waste of money. However, I do endorse consumption of fermented foods. Why? Well, these are time-tested methods of preserving the nutritional value of foods without ultra-processing. So, in a way, they're good prebiotics. They also contain postbiotics, which may actually be beneficial to the gut. There is growing evidence for that. So, after all this detour, were these early investigators completely wrong or were they right about anything? Well, I give them credit. They recognized the importance of the gut microbiome in the body, even if they viewed it with too much suspicion, didn't have any technologies to study it. In fact, Louis Pasteur believed that a germ-free animal would not even be viable. But it is, but it's not normal. This auto-intoxication theory may not be completely wrong. In fact, both the microbiota and its gut environment, that is, the microbiome, does change with advancing age. And it is now being recognized that these changes are associated with this chronic inflammation and inflammatory diseases that come up with aging, so-called inflammaging. And that could be a whole topic for a whole talk. And it's true that there are microbes and entire microbial communities, and that really is the new paradigm that we have to think not just individual microbes, but them as communities, as potential drivers of many diseases. So here's an example. There is very concerning rise of colon cancer among young people. Now, it's still much more common in older people, but every year there's about 3% rise in the incidence of colon cancer uh, among the young people. It's really tragic by the time these, they often are discovered, maybe because of rectal bleeding, and you find, oh, it's already spread all over the body, and the patient is only 35 years old. It's not understood what's the driver of this, but it's documented all over the world. And people speculate maybe it's obesity, maybe it's low fiber calcium diet. But there's a lot of evidence emerging that is the altered microbiome. If you think about it, that is the fastest changing part of our bodies. And now there are um, actual candidates for microbial drivers of colon cancer. So here on this um, cartoon, on the left-hand side, you have a healthy colon, and you see this top green layer. That's the mucus layer, and that's a very healthy gut barrier. Then you have the lining of the cells, which are colon's epithelial cells. Colon cancer comes from them. Underneath that is the immune cells and various connective tissues. And is a specific group of bacteria that produce a substance called colibactin. They're mostly E. coli species. This colibactin, if it penetrates to the colonocytes, um, it, it it acts as a mutagen. That is, it damages the DNA in a very specific way, and it actually targets preferentially colon cancer genes. And it's well documented that the prevalence of this microbe is increasing in the population. About 30% of people in industrialized countries carry this microbe, and we've documented it in our own experience. Um, it's probably not enough by itself to cause colon cancer. It's a very early step in colon cancer development, but it can work in together with other microbes. For example, this other one, enterotoxigenic B. fragilis, which feeds on mucus. So if you have a mucus degrading microbe, as well as this colibactin producing E. coli, so now the gut barrier function is weaker. The colibactin mutagen gets through to the cells easier, and there you have initiation of the colon cancer progression. Uh, it probably happens in fairly early in life. It is now seen that in this young people, when you look for the specific signature, and we have a chemical signature for colibactin mutations, it is more prevalent uh, in this early onset colon cancer. And it's speculated that it's probably the damage starts in childhood, maybe even age 10 or so. That's just one example, but it's been noted now for decades that the whole epidemiology of disease has shifted. We used to have infectious disease, mumps, measles, tuberculosis, rheumatic fever, and that was largely defeated. Not completely, but it dramatically went down. And as these diseases went down, you had a rise of other diseases: diabetes, asthma, allergies, multiple sclerosis, inflammatory bowel disease. These are far more prevalent than they used to be. So this was basically summarized as the hygiene hypothesis. There's something going on that in the initial version of it, it was thought, well, the immune system is just not getting the right training because it's not experiencing the right infections, and then it goes berserk. Um, but it's been updated, and the focus is now more on the microbiome. Our microbiome has changed. If we look at, if we can still find them, some ancestral populations, and you look at their microbiome as it compares to the industrialized microbiome in the gut, the ancestral one is far richer. There's more species of bacteria. We've literally starved and killed them with antibiotics in our industrialized world. Um, it takes, as you can see in this figure, it takes about 3 years for the microbiome to develop. So it has a developmental phase, just like all organs. And we've mucked around with that in our society as well. So if you think about how babies even arrive in the world, the very first day, just being born, 15% of babies in this country go through C-section. Well, when you pass through the vaginal canal, you get the first inoculum of bacteria. Most of them don't make it because the newborn physiology is not receptive, it's not hospitable to most adult microbes. But that's how things start. The whole trajectory is different if you're born by C-section. The first microbes come in are from skin of those of caretakers. And then all these different changes. There's antibiotics. There is perhaps no breast milk. The breast milk itself has its microbiome and it's changed. Um, are there pets? No pets. Um, what kind of environment is the baby um, exposed to? So that may very well be a very critical stage in microbiome development when a lot of other systems get set up, including your immune system, nervous system, energy system, and we still don't understand how all of that impacts life. And so now we kind of move to what we're doing. So the way I entered this field is because of this specific disease. This is C. difficile infection. It happens. This was my first patient. I was a 61-year-old woman who presented to me with chronic diarrhea. At that time, it was going on for 8 months. It started with antibiotics. She's had several hospitalizations, was dehydrated, was treated with more antibiotics, and it was really miserable. She was literally having bowel movements every 15 minutes, day and night. She was confined to a wheelchair, lost about 60 pounds of weight. And she came to the university as her last hope. And this is the disease. So, C. difficile is a bacteria. You don't just get it. You have to be in a vulnerable state. And that vulnerability is typically induced by antibiotics. So if you think about it, you take antibiotics for any indication, it's like you're throwing a grenade into your colon microbiome. It disrupts that community. And briefly, there is that period of vulnerability. And the patient comes into contact with C. difficile spores of the bacteria, and they land in the colon. They'll wake up and make toxins, and that causes inflammation and diarrhea. And the patient goes to the doctor, they give him more antibiotics. Those antibiotics will kill more of the normal bacteria, but often unable to extinguish C. diff, and the cycle repeats. And this is what was happening to this patient. And it was known actually for decades. What you have to do, you infuse a fecal slurry from a healthy donor, and that abrogates the problem. That's what basically we did. That was back in 2008. And this is what happens if you study it at a microbial community level. So this is a very, very schematic, only focused on some key bacteria whose names are completely irrelevant. But what you see is there's a community. The green lines connect relationships between collaborating microbes. Red lines, they may be competing. In the middle, there's the patient before they got this treatment. And you see a lot of these microbes are gone. Whatever are left are different microbes, and they all seem to be hating each other. And then 1 week later, you see a complete normalization of the microbial community structure. And you think about it, there is no probiotic that could ever fix this because there you're talking about one or a couple strains of individual microbes. Here we're talking about really repopulating an ecosystem, and that's a paradigm change. I did it. A bunch of other doctors were doing it around the country. The FDA heard about it. They called a conference back in 2013 and said, well, when you do something that's used to cure, treat, mitigate, prevent disease, it's called a drug. So if you're going to do that, there's a whole process for doing that. And that's a different talk, but basically we kind of embarked on that journey. And so at the university, we have a facility that is able to manufacture investigational drugs for early phase clinical trials. And the FDA let us do it for treatment of C. difficile infections as well as supporting various clinical trials. It is a so-called GMP facility uh, that is good manufacturing practices, that is operating in accordance with pharmaceutical standards, meaning that every manufacturing run is standardized, and the FDA can walk in at any time and check every point of that manufacturing process. There's quality control systems, there's material management, there's quality compliance, all kinds of critical control systems. This is the way really drugs are manufactured. And so it is a unique facility, academic facility in the country. And for that reason, and also with the help of Achieving Cures, together, we're able to support a variety of clinical trials all across the country for all kinds of indications. Not surprisingly, some of them are focusing on digestive system disorders such as ulcerative colitis, Crohn's disease, um, primary sclerosing cholangitis. Um, we have a big direction in gut-brain connections with studies in autism, an ultra-rare syndrome with Pitt-Hopkins syndrome, uh, alcohol cravings that's supported by NIH. There's a lot of interest in modulating the immune system, and we have studies in food allergies, particularly peanut allergies with Boston Children's Hospital. Uh, Alopecia areata is an autoimmune disease that affects hair all over the body. And they have a trial ongoing between the University of Minnesota and Columbia. There's a lot of interest in um, using targeting the microbiome to optimize cancer recovery, whether that is complications of bone marrow transplantations or immunotherapy with checkpoint inhibitors. A huge problem that's emerging in medicine is antibiotic resistance. In a way, C. difficile is one of these manifestations, but there's many other drug antibiotic resistant organisms, and many of them emerge from the gut. If you think about it, gut is kind of the central plate. It's the central hub of microbial evolution. The microbes are literally rubbing elbows. They're passing genetic information between each other. And so if one microbe has antibiotic resistance gene that favors it, it's able to pass it on to other microbes, even if they're completely unrelated. That's how bacteria function. Uh, and so we know that, for example, that patients with a recurrent C. diff infections not only harbor C. diff infections, they harbor many other antibiotic resistant organisms. And there's a lot of interest. What if you can make the gut healthier in with that dimension? Um, and with that, there's a lot of work to be done. Uh, the therapy that we're developing is called microbiota transplant therapies. That is unlike C. diff, where you just have to give a small inoculum of microbes to a decimated microbiome and things uh, recover fairly quickly. In most of these other indications, the regimens are far more complicated and more rigorous and require a lot more treatment. So they could be several months of oral capsules. These are different formulations. Oral capsules is probably our workhorse, but we have even some in powder for the children. It can be put in a liquid and they can drink it. And our mission is help patients with C. diff infection. That was our original mission, and we still do that. And with the help of Achieving Cures, we're able to offer therapies to patients free of charge without struggling with insurance companies. A major mission is to support early phase academic clinical trials. Uh, and of course, we're working on how to move this therapy forward for these different indications. And my thanks to Achieving Cures and other funders, and of course to our stool donors and various collaborators. Thank you so much.
Thank you so much for your presentation, Dr. Khoruts. Your dedication to expanding this vital area of medicine and health is truly saving lives and improving medical care, and we're really grateful for your time tonight. We now have an opportunity to answer questions. As a reminder, you're welcome to submit questions through the Q&A feature on Zoom. We do have a couple that were actually emailed before the webinar started, so we'll start off with those and then move through additional questions as well. So the first question is, how often is FMT successful for C. diff, and what are the options if it fails? And I wonder if you could add on to that, what are the current options for patients with recurrent C. diff infections for treatment if they're interested in FMT?
Sure. There is a spectrum of disease with C. diff. I made it sound like it's fairly simple, but I've been working with C. diff for 2 decades, and I'm still learning about it. The most common indication that we see in clinic is this problem of recurrent infection. And the goal is to prevent recurrence. And with some of this work actually driving the field, there are now two microbiota-based commercial products that can be used to terminate the cycle of recurrence. One is an enema formulation from Ferring Pharmaceuticals. The other is um, a Nestle Health product, which is made of bacterial spores, which is given as oral capsules. Of course, those come with restrictions imposed by insurance companies, and can be pretty expensive, not available to everybody. But those are FDA approved, and commercial insurance often does cover them. They're not available for pediatrics. And also, there's a huge, important gap that still exists, and that is for treatment of C. difficile infection. So some patients are in the hospital and they have a very severe C. diff infection. And actually, most of the deaths, which is about 30,000 deaths per year, is attributed to C. diff in the US. Most of that is driven by acute mortality, driven by severe infection. And we've shown that if you do administration of donor microbiota in that setting, that can be life-saving and prevent surgery. There's no approved formulation for that. So it's difficult to compare necessarily commercial products with FMT formulations. When the American Gastroenterological Association tried I mean, it's without a direct head-to-head comparison, it's difficult. So you're just kind of looking at different studies and making an educated guess. The FMT was actually a little bit better than the commercial preparations. Um, and but even if they're all the same, the efficacy is somewhere between close to 90%, 80 to 90% in terminating the cycle of recurrence. Uh, we're fortunate in the fact that we don't have to struggle with insurance companies, and we treat patients based on medical judgment alone. Um, and so that's an extreme privilege to be able to practice that kind of medicine. So we get the most complex patients, um, and It's about the same 90% success rate. And if they fail, we try again. So we can get it up to 98% or so. Uh, with severe infection, that's a different beast. And we've just recently established a system that involves 6 local hospitals, some community, and of course, university, to actually identify patients who have severe infection and intervene when necessary, not sometimes with FMT, but sometimes with just adjusting their therapy and making sure that they're not going to run into recurrence in the future. So we have um, a system, a quality improvement system to identify them and get to them early. And so I think that's making an impact as well.
Thank you. Our next question is, have you seen any regressions or neurobehavioral issues in patients post FMT? If so, how long do they tend to last and how are they treated?
Um, so FMTs, they're done for C. diff problems, and those tend to be very sick patients. So it's a very complex population. That's not really the way to address that problem. Um, I think one needs to really look at clinical trials that focus on the specific problems. So, as I mentioned, we have uh, a large direction, for example, targeting autism. And study after study, we've done now 5. Um, they're not all published, but we're seeing benefit over placebo. Now, it's of course, that's a very complex disorder. There's probably multiple drivers. We still need to identify, just, if I've been working with C. diff for 20 years and I still have things to learn, I need 200 years on this one. But the there's probably some patients who would benefit more. We have to find who those are. We do know or anticipate that certain donor selection may be also a contributor to benefit. But uh, without a question, there's a signal there. And of course, other investigators are doing these studies in all kinds of neuropsychiatric disorders. These are small studies. There's promising signals, but we're still at a very early stage. We're probably doing the biggest ones that are placebo-controlled. Um, so it's a little early, but there is true hope there. Certainly not enough for all the hype that you might be seeing, that somebody's going to cure your gut with some simple intervention.
Thank you. The next question we have is, what was the biggest hurdle in convincing the medical community that FMT is a legitimate therapy?
Hmm. Well, I'm not sure that's necessarily done. Um, have we convinced if all? I mean, for clinicians who have ever seen it in action, they don't need any convincing. It is almost miraculous. The patient I did, the very first one that I mentioned, we did it by colonoscopy, and she at that point is suffering for 15 months. And literally in the recovery during after her colonoscopy, she said, "I feel different." That doesn't always happen like that, but she didn't have a recurrence then after that. Um, when people have severe fulminant disease and they're on a ventilator and medicines are running in to support their blood pressure, and you do this procedure, and then next day they don't need the blood pressure medications, they're off the ventilator. I mean, that's dramatic. And if you didn't do that, they'd be dead or lost their colon. So those who've done it are convinced. Convincing the FDA, convincing the larger medical community, that's a that takes a lot more. And there's many different forces in this world to uh, establish something as standard. Um, And even once it's standard, there's still work to be done to make it better. The FDA approval for something is not the end. We still have a lot of things to learn.
Definitely. Well, thank you. And I imagine those patient experiences are really rewarding for those providers and life-changing for those families. So thank you. Our next question is, beyond recurrent C. diff, where do you see the most promising evidence for microbiota-based therapies next? For example, metabolic disease, mental health, or others?
Um, there is a lot of promising directions for sure. There is a clear signal in ulcerative colitis. Um, a lot of work needs to be done to make that signal better. Uh, but study after study, last I looked, there were like 12 or 13. They were better than placebo. Crohn's disease may be a little harder, just because it's a more varied in presentation. So inflammatory bowel diseases is one area. Uh, we did a fairly large study in advanced liver disease, and that is maybe not a surprise because the specific indication was hepatic encephalopathy because the liver is not clearing toxins, and all standard therapy is actually targeting the gut microbiome with a prebiotic um, called lactulose, an antibiotic called rifaximin. So it was perhaps not a surprise that when we added FMT to that, there was benefit over placebo. So that's going into a multi-center trial now. Uh, things as there's a lot of promise in improving cancer therapies. That seems pretty solid. Um, have hopes for things even like kidney disease, kidney stones, because there is a connection between the colon and the kidney stones, um, and different version of this. Um, but I do see this as clearly as an important frontier of therapeutics development with millions of people potentially to benefit.
Definitely. Well, that work is all really exciting, and we're grateful that you're able to share the advancements with us. Thank you. Um, Next question kind of circles back, pairs off of a previous response that you gave. How do you choose a stool donor? And if I might add, does that vary by clinical trial?
Right. So when we started with C. diff, um, our sole criteria was identify the healthiest people. So it's really by donor health. Most of it focused on infectious disease, but we also said no neurologic, neuropsychiatric, no immunologic problems, no history of no prescription medications. They have to be absolutely healthy. And why? It's because we don't have a test that can say this is a healthy gut microbiome. So we go by proxy of healthy individual. Of course, we study their microbiomes, but still, that's how the selection is done. For C. diff, that is perfectly sufficient. Uh, for other indications, that's research work in progress. There may be differences in donor selection when you're talking about autism, and we're seeing some initial results of that. Um, we've seen differences in this hepatic encephalopathy as well. And our hypothesis is that prebiotic that is standard therapy requires microbes to work on it. And different microbes in different people, different microbiomes have different ability to metabolize that one prebiotic. So that's the selection scheme. Um, for other indications, we're not quite sure, and you just have to do the trials to try to figure this out. So we are actually embarking right now with really minimal resources, but hopefully to grow that to really increase our donor base. So um, the donor program that we have is the oldest in the world. Um, and we really wanted to make sure it's adhering to not just standards of different tests and such, but also the highest ethical standards. The reason being is because That was learned in blood banking, that if you just pay people, and that's their motivation to participate, that has a certain moral hazard, and you can't totally trust them. And our donors essentially they live in a surveillance program, so we know all about their travel and their diet and everything. So it's a commitment to become a stool donor, both for the donor and for the program. But right now, because exactly of this question, that we need to explore the variability in microbiomes for different indications, we're trying to increase the ranks of our donors. And so there is a active study that we're recruiting for donor candidates. Um, of course, we would study their microbiome and look at their diet and all kinds of metabolites, and somehow stratify them in categories.
Thank you. I'd like to add, if anyone knows anyone interested in becoming a stool donor, we do have a section on our website with information, and we can help you get connected with the stool donor coordinator as well. Thank you. Next question is, what is the status of the oral FMT trial for ulcerative colitis?
Yeah, so this trial is FDA approved. Um, it is now going through the our local IRB. We hope it'll be running still this year, probably the last quarter of this year, but it's reasonably on track.
Fantastic. Um, Thank you. And then the next question we have is, why do kids with autism have frequent urination, even if they are not constipated?
Some kids with autism, some more than half have GI problems. Maybe some of them have. I can't say that I am an expert in autism. I'm a gastroenterologist, an adult one, and now I've learned about manufacturing and microbial ecology and all kinds of stuff. Um, just I'm learning more about autism, and what I'm seeing is that there is a huge spectrum of different different symptoms, different behavioral manifestations, and I'm sure there's different mechanisms how they drive a common mechanism in the end. So, what could drive frequent urination? In general, if we just forget about autism and just think about frequent urination, um, I'm assuming it's not infection, but there's an entity called irritable bladder. Uh, and a lot of patients with autism, they have hypersensitivity to many things. They have a lot of GI symptoms. It's part of that hypersensitivity. They may be suffering with abdominal pains, constipation, occasionally diarrhea. It could be the same kind of, I'm just speculating, the same kind of a circuit, whatever is aggravating their various hypersensitivity. They may be hyper reactive to loud sounds, for example, or to touch. Their bladder may also be hypersensitive, and that could be a potential cause. But it's just a speculation. But one thing I've looked at as a researcher, like, okay, what do we know? When you're talking about autism and you're starting talking about mechanisms of disease, how much research is really being done mechanistically outside of psychiatry? And there is not much. As a gastroenterologist, I thought, okay, I kind of understand constipation. There could be slow transit, or there could be an outlet problem. There are simple tests to distinguish those. Has anybody looked in autism? Challenging because the severe autism patients are nonverbal and they're not easily communicating what the symptoms are. It's hard enough in regular patients. Well, so I looked, have these tests been done in autistic population? And I found zero papers. Nobody tried. It's too hard, I guess, People just, whatever, they have other populations they focus on. But yeah, it's a there's many areas of huge need for this really often devastating problem that is taking a toll on families and the patients.
100%. Thank you for your insight on that. The next question also revolves around autism. And so this question asks, for autism, is microbiota transplant therapy the only solution for gut dysbiosis? A lot of functional medicine doctors use antifungals and antimicrobials paired with probiotics. If this is ineffective, how far away is microbiota transplant therapy for autism?
Um, so yeah, it's been noted a while back that vancomycin, an antibiotic, has at least transient beneficial effects in autism. Similarly, antifungal therapy has been noted to have benefits. Um, it's not clear how sustained that is. Trying to consolidate it with probiotics makes no sense, just because those are not the right microbes. So that was the idea of microbiota transplant therapy, is that you actually would start with antibiotics and then you consolidate with administering different microbes in order to restructure the microbial ecosystem. As far as I would think, that is the most powerful method to try to achieve that. Um, and probably nutritional therapies are important, but the problem with nutrition alone is that it depends on what microbes are there. So if you don't have the right microbes, you might not have the expected nutrition outcome that you may wish. So I think is probably should be incorporated into the microbiota transplant therapy as well. How far is it? Still ways to go. Um, the we've done several placebo-controlled trials. They show benefit. We're trying to fundraise for more. Um, so the investigator that's leading that work is Jim Adams at Arizona State University. He's easy to contact, and you could write him an email, and he'll tell you what are the options. And he's involved in many autism other directions as well. He's got a nonprofit that's um, has some vitamin therapies and recently established a diagnostic lab. So one could ask, why should this therapy work at all? How does it work? Uh, and so, as I mentioned, there's the microbes make certain neuroactive compounds, and they can be measured. They can be even measured in urine of patients. And so, it looks like you can make a diagnosis of autism um, based on the urine tests, or at least get some idea what kind of metabolites may be a problem. It's not a clinical test that is not FDA approved. It's still um, heavily being researched, but it is available.
Thank you so much. The next question asks, when will FMT be more readily available to other types of GI disorders? This commenter has leaky gut and an older generation that was given more than ample supplies of antibiotics and microbiome changes during menopause. This person went to the UK to get a 2-week dose, but since has discovered it takes 30 days to seed in the gut. So any comments that you would have for that particular commenter?
Well, in the US, the only allowed indication in the clinic is C. diff context. So physicians are still able to provide FMT for that one indication, even without the commercial products, except that nobody really does it, because that provider has to be also the manufacturer. Um, so we're able to do it, but only for C. diff. For all other indications, there needs to be a clinical trial in this country. And this particular problem, um, which is unfortunately not uncommon, and it's probably the most frequent email I get. Um, I'm not aware of a clinical trial for this indication specifically. Um, and it would be probably difficult to obtain even a compassionate care option through the FDA, um, given the restrictions they have for that path. Um, so that's why people go outside of the country and search for some clinic. But of course, the danger is we don't know how rigorous those places are and what kind of science they've done and what do they know, um, and what kind of regimens they use. If somebody tries to restructure the microbiome, as I mentioned, a C. diff like FMT is just not going to work. It requires a very much different protocol, much more rigorous, much more intensive, because you're not dealing with a decimated microbiome to start with. You're really trying to restructure something. Um, and of course, that may or may not be the problem because the we're talking about the microbiome, but the gut is much bigger than that. It it has there's a lot of physiology aside from the microbes that may be relevant.
Thank you so much for your insight on that. The next question, I think relates to an answer you gave before. I'll read it out loud and see if there's any additional comments you have relating to looking for access for microbiota transplant therapy for autism. So this commenter states they've been desperately trying to help their 21-year-old autistic son who suffered for over 15 years from gut dysbiosis, which results in severe self-injuries and aggression behaviors. How can I access MTT therapy for him, microbiota transplant therapy?
Yeah, so outside of C. diff, we have either clinical trials or compassionate care um, mechanism, uh, where an individual gets treated with a special appeal to the FDA. It's kind of a resource intensive process. We've done it on occasion, um, with some, but inconsistent success. But for the most part, patients benefited. But it is quite a journey to get it done, and it's resource intensive to get there. So that would be the only option available right now. I think Jim Adams is trying to put together a clinical trial as soon as he can. He's in discussions with the FDA to try to see what can be done when the resources are scarce and the demand is high. And he gets lots of emails like this, and so he's trying to find a way to get another trial off the ground.
Thank you. And I think, as you mentioned before, on his website, he does have a contact list for that he does send updates out with new clinical trials if anyone is interested in joining that list as well. The next question here, it looks like is coming from a former patient. And so this former patient says, "Hi there, Dr. Khoruts helped me with C. diff relief and with the transplant 2 times. I'm so grateful for his care. My question is this: soon after C. diff, I was diagnosed with RA, rheumatoid arthritis. Do you think that there is a correlation between the two? Would you have any, also had blood tests done for fatigue, all labs look fine. Would you have any advice of considering the issues with fatigue with gut health since all the labs are coming back good?"
So the question the one possible question is did all the C. diff illness that happened, because there usually is a prolonged illness struggle with C. diff before FMT is done, did that cause um, rheumatoid arthritis? Is there a connection like that? Or second is, could the FMT itself, the therapy, the new microbes triggered an autoimmune disease? Um, so people have looked at that, and we've looked at that. We're not finding for the latter question that there is a signal that FMT triggers autoimmunity. We still list it as a possible adverse effect. We've never seen it. We list it because, well, we have to be humble before the complexity of nature. And we're talking about very complex systems. So, um, similarly, the lead up with all that C. diff illness when the microbiome was bombarded with antibiotics. And in that setting, when you give a lot of antibiotics that are killing the gut microbes, there are surviving microbes, and those survivors are often not the friendliest. They tend to translocate, they crawl into the host, and they cause more inflammation. So it's conceivable. There certainly are connections between GI infections and autoimmunity. Um, Rheumatoid arthritis itself doesn't come up as top of the list of what the triggers may be. Um, but that's probably if there is a connection at all, there may not be. That probably is the more plausible one. But, rheumatoid arthritis is a common autoimmune condition, much more common in women. It just maybe that's just the way it was going to happen.
Thank you for your input on that. Really appreciate it. Um, the next question that we have here is a stool sample study suggested that I have no bacteria or good bacteria in my gut. How would you suggest I proceed?
A test that established there's no good bacteria. That was right.
Yes, so
What
they
said.
wrote that they had a stool sample
Mhm.
study that
Mhm.
suggested that they have no bacteria. I'm guessing no bad bacteria or good bacteria.
Yeah, I'm very skeptical of the direct to patient or direct to consumer labs that peddle microbiome tests. It's been shown multiple times. If you just take the same stool sample and send it to a couple different of these labs, you'll get different results from each one. It is a very complex tests. They're not standardized. They're not meant as diagnostics. So I never really look at them as particularly informative. They often lead one in some potential rabbit hole if there's something shows abnormal. Uh, Having said that, as I kind of went through the talk, we don't have a test that can say everything is normal. I can usually look at the microbiome, like our analysis, and see, that doesn't look quite healthy. Usually the microbial diversity is lower or some expansion of certain microbes that I wouldn't necessarily characterize as good or bad, but just the relative abundances of them are off. Uh, but is that a cause of a problem or is it a consequence of some problem? We can't really tell. And I'm not sure it's diagnostically all that useful.
Mm.
I think a lot of these questions come from a deeper problem of our healthcare system that you know the we have a healthcare system which is focusing on procedures where time with patients is perhaps less than it should be, um, and um, you come with a complex problem with complex set of symptoms. They give you a fiber prescription or something else, and then have you come back in 6 months, and that's just not the way these problems should be handled. A lot of patients suffer with symptoms of bloating and nausea, and these disorders of gut-brain interaction. Um, if done well, these patients can be helped to about 80%. But that involves attention on the GI health psychology, diet, maybe some medications. And that's like without any microbiome considerations. That's just looking at the patient holistically. I think that's more important.
Mm. Thank you. There was a clarifying question that just came through, wondering wondering if the test is referring to a test called Omber. I'm not sure if you're
Not
that's familiar.
necessarily. I can't keep these. their proliferation of these tests.
Mhm.
Last I looked, there were like over 30 companies offering these tests.
Mhm.
They're, they look impressive. They usually give you a book of all the different microbes and certain pathogens and inflammatory markers and short chain fatty acids and all that. Um, but as I said, the testing is very complex. That's one problem. Second problem, you're looking at a stool sample. A stool sample is a very distorted window of what is actually happening in the gut because it's just not a bag of microbes. It's a very complex environment there. And there are microbes that are sitting on the lining of the colon and maybe and microbes in the small intestine, which are much fewer in number, but probably not less in importance. Um, some microbes are in the middle. So when we've actually looked at doing a biopsy during colonoscopy and asking, is that representative? Is that similar to what you see in stool? The
Mhm.
answer is actually it can be dramatically different in patients who actually have some gut problem. So I'm not even sure the stool test in many cases is the right test.
Mhm.
Uh, so yeah, there's still many questions on how to do this properly.
Thank you. And I think as you answered that question, I think you kind of delved a little bit into the next question here. So I don't know
Okay.
if you have more to add, but asking if the University of Minnesota lab that you founded conducts stool sample analysis, and maybe if you could talk about when you would do that type of analysis versus a colonoscopic microbe
Uh,
analysis.
because we don't really have a clinical reason for this, we don't offer just a stool test or any kind of microbiome test to help with the diagnosis of the patient. Um, we haven't developed a test like that. We do study the microbiome. Our focus right now is characterizing the diversity of healthy people because that's our donor base and understanding as much as we can in the biology of the microbes there. Uh, but we don't have a lab. We don't have a test to help with diagnostics. Uh, and as I mentioned, there's many companies that may imply that they do, but they don't. And what is somewhat, also we're in the age of big data collection. So you send your sample to them. If they're smart, they're actually doing research and they're analyzing all this and they're using your data for some future um, purpose um, without really getting an informed consent that you're helping their business and you're literally paying for their research. That also kind of bothers me.
Thank you. It looks like we don't have any current questions. Just want to thank you so much, Dr. Khoruts, on behalf of the whole ACT community for your time this evening and for the life-changing research that you're leading. I also want to thank everyone who joined us for today's webinar. I am just sending that link through the chat with our website listed on it. If you have any additional questions, feel free to reach out to us at info@achievingcures.com. We also have some resources on our website. Feel free to browse through and let us know if you have any questions. We will have the recording of the webinar available within a few days here and email that out to all the participants. And please feel free to share. Again, reach out with any questions as well. If you have any recommendations for topics you'd like to hear about in future webinars, we would appreciate your input and your feedback. Thank you again so much and hope that everyone has a great night.
Thank you.
Thank
Bye.
you. Bye bye.